yes, we're going to talk about adventures in TensorFlow.js. So I want to start off with some questions because this presentation is extremely awesome and dynamic. I can spend more time in technical if people are very used to AI and machine learning, or I could spend more on sort of the inspiration and the tips if you are somewhat new. So what I'd love to get is from the audience, tell me in AI and machine learning, how much experience do you have? Say AI colon, and then a lot, a little, none, all those different things. That helps me out a bit. Newbie, perfect. Things like that help out. Yep. Yep. Okay, perfect. Good. Good, good, good. I promise you, you will all have fun with this. So that lets me know a little bit about the audience. Now, one more thing I want to kind of find out. Go ahead and do JS colon, and then tell me how much experience have you had in JavaScript. Just want to kind of check that a little bit, because this presentation might as well be called Adventures in AI and JavaScript. And if you've had none of either, that helps me out a lot. So, okay, let's take a look. Okay, so we've got some lot in JS. I see a 0 in JS 5. I hope that's out of 10, or maybe that's out of 5 stars. Who knows? We'll go with the medium. We'll say that that's around halfway there. 7 out of 10. Okay, good. So I won't pull any punches for a second here and saying like JavaScript. I'll kind of expect you to know a little bit about JavaScript. I'll expect you to know nothing about AI. And that's how I'll kind of present this. And hopefully that'll help out a little bit. So who the hell is this guy talking to you, right? That's important. Why should you even be listening? One, I am the CIO of a wonderful company called Infinite Red. We do all kinds of JavaScript consulting. Mostly we do stuff in React Native, so I am a React Native core contributor. But in the essence of this conversation, I have 2 different points there that are really kind of key here. Is that one, I am a Google developer expert in web, and I am a Google developer expert in machine learning. So you can see that I actually have Google representation and tie-ins to their teams on 2 specific things. One, web, and the other one, machine learning. So I think that makes it great. That also made it perfect for me to become an O'Reilly author. I have written a book, which I'll kind of mention a little bit later as well, about exactly this. So I better know what I'm talking about. If you're interested, definitely, I do all kinds of crazy mad science stuff. I have all kinds of fun things, and I'll be giving away a free course. It's a $300 course, US currency, $300, and I'll be giving it to one of you for free on Twitter after this. So definitely follow me on Twitter at Gant Laborde, and I'll be giving you that presentation for free. If you're wondering which one it is, it's the person who's got all these crazy little icons of them. If we were in person, I would be giving you stickers with all these cool little things and all the superpowers that I like to have my icons have. But we are virtual, so you just get to look at them from afar. This is Gant Village. This is where all the science is done. So perfect. So I saw a lot of people say that they're new to AI. And to be honest, I think that we need to kind of take a second here and talk about what is AI. And honestly, if anybody's been coding for a long time, AI meant something different 20 years ago. It meant something different 10 years ago. AI was really cool because if you all play video games, I'm sure, you have this character who's sitting there playing with you that's not a real person. It's this amazing feeling that you're able to play against this sort of like fictitious computer programmed AI, and sometimes it's complicated, sometimes it's set on easy mode. And the way that was handled originally versus how that's moving in the future, now we're seeing AI do all kinds of new things like, finish your emails for you inside of Google Mail, add cool faces on you inside of like fun apps and things like that. Perhaps it's even like helping you identify all kinds of crazy stuff inside your business and things like that. Fraud detection, it's even all over the stock markets because it's helping bots trade. So AI's changed a lot, and we got to take a second and talk about why. Why is it like everywhere now? Because if you've been coding for a while, AI wasn't this popular, but now it is. And is it reaching an apex, or is it just about to do more? And the truth is, there's this thing called neural networks that sort of were around for forever, but we had some problems. One, computers were too slow. Two, data was too sparse. And three, just getting all the algorithms for these kinds of neural networks were just very simple and very like rudimentary, and we're solving very simple problems. Today, everything's data. They call it the new oil. They're talking about how important data is. And yes, whoever's asking, you are muted. Don't worry, I can't hear you. Secondly, it is because, you know, otherwise I'd just be hearing wow over and over again, right? So what happens here is we have this fantastic opportunity. You have GPUs, you have excellent algorithms, and everything is data. So now we can finally start teaching a machine with data. And this creates things that we have never seen before. That's what's exciting. That's what I really love about this. So, by the way, I just want to kind of do a check real quick and make sure everybody's actually enjoying themselves. And what better way to make sure everybody who's watching this talk is enjoying themselves than to do a little AI experiment. Are some of you okay to do an AI experiment? Yes? This will require that you you enable your camera for a second. Don't worry. So I want to make sure that you're actually enjoying the show right now, right? This is important. So I want the following to happen. So I want us to, I'm going to pull over a website real quick. I'm going to go to enjoyingthe.show. And then I want you to go to join a room here. And let's type the word demo. So you can see this right here, and then you hit go. When you hit go into joining the room, it'll ask whether or not it can access your camera. And I promise you, it will not send your face to me at all. I'll show you exactly what it's sending to me. So I'm going to go watch the room demo over here. So I'm going to go here and say, I'm going to watch demo. So you're going to join it. I'm going to go to watch. So here we are, and I'm loading, and this is the demo room. So right now, yeah, it's enjoying the show. Oh, I can see one person's hopped in there. So there's a person in there, and now it's asking that one person for their camera and access to things like that. And then when they say yes, it'll kind of load a model and check out a few things, and this will show you what's going on here. Oh, I see 2 people are in the room. Fantastic. So if you're uncomfortable with this, we already have 2 people. You can go ahead and stop if you don't want to do that. But we need them to go ahead and turn on their cameras and let it kind of make sure the cameras can see their faces. And that's how this will work. So we get 1 person, 2 person, 3 person. Okay, so 1 person has their camera loaded and they are set in here. I'm going to ask you all to smile. There you go. There's half the room smiled just now, and then went to neutral. So can I get everybody to smile again into the camera? Now it does need to have like decent lighting, and I know you look crazy at your desk right now. There you go. So we have some people in neutral. We have that's 3 people smiling because we got half the graph there. It's perfect. Now feel free to make some other faces. Have fun. Get angry. Oh, we get some more smiles there. Good, like, I'm angry. Oh, I saw sad. Don't be sad. Surprised. Good. Like, it's hard to be angry, I guess, set there. So yeah, so here's what's a great thing that's happening. We're all in a virtual world, but if I left this up during my presentation, I would be able to see how everybody's actually enjoying the presentation. whether or not you are actually enjoying the show at a given time. So each of you, as you're looking at this, if you're watching this on recording, the people who are looking at this get to see their own facial expression, and they get to see what they're being sent as. And then that string is being sent over the network and being live updated. Half the people are happy. Half of you are angry at me. So, and now people are having fun just doing different stuff. So imagine this with a room full of 100 people. You'd be able to tell if that joke landed. You'd be able to tell if you said something that surprised everybody. If you were doing a presentation in person, you could point a bunch of webcams at the audience and find out whether they liked your presentation or not at any given moment, or if they're all angry. So people are right now. So it's a lot of fun. It's a really cool kind of experiment. But how is this all kind of working together? The answer is AI plus JavaScript. I'm getting a live update of this fantastic set. And this demo, by the way, if you ever want to do this website I made for 100% free. So if I go back to the main page, and thank you everybody who participated, you can feel free to close it down. I'm not going to be watching any kind of expressions anymore. But if you watch the traffic that's going over the wire, it's simply sending a string. And that's how I'm able to like scale these people together. I don't have to send your entire face. Your browser is looking at your face and identifying your sentiment and sending that over the wire. None of that's hitting my server. And that's how I'm able to make this 100% free. If you ever want to kind of show this to someone, you can make up any room name for room to watch and any room name for what to join. You can even send out the link to people, and then you can kind of see it live in action. Here's me testing it with some friends, just kind of checking it out. So we're all making the faces together at the same times, but it's fun. So yeah, what did we just see? Well, we just saw AI in JavaScript. And that's just one of the cool, fun experiments of things that you can actually do with this, and why I think this is like amazing and powerful. And thank you for whoever said this is cool in the comments. Yes, it is. If it had trouble getting your face for some reason or another, you never know. Sometimes maybe you might be related to Nick Cage. Apparently AI has trouble with him anyway, but it's totally okay. So that's a little bit on why machine learning, but let's get a little bit further into it, right? Why is machine learning cool? Because I know a lot of you were saying, I know very little about this. And the trick is that algorithm, for facial recognition and sentiment analysis is useful in a bunch of other different ways. I actually just saw a research study that happened recently where they were trying to identify an AI to identify different types of pastries, and that AI was also some reason able to immediately identify the different types of cancer, and it was really cool. So, for instance, let's say I was going to make Grammarly tomorrow. I was going to do like a grammar check, and I was going to do it in English. I have to go get a PhD, and I'm coding all this stuff, and I do it in English. Well, now let's say I need to go do it in Spanish. So now I have to go get a PhD and figure out all the grammar in Spanish? That's hard. Or I feed the AI 10,000 US English books, 10,000 British English books, and 10,000 Spanish books with excellent grammar, and it learns from the data. I get to code this once, and then I just have to worry about it after that, feeding it different data. That's the benefit of machine learning. It's the power that comes along with that. And large companies are absolutely just leaning into this. Google, as of the end of 2017, went from less than 4 machine learning models in production to over 4,000. I guarantee you it's everywhere inside of Google. This number's old. It's the end of 2017. I don't have any new numbers, but I can tell you it's probably exponentially grown from there. So what does machine learning do? Well, everybody's seen cool things like deep fakes and fun stuff like that. We've seen apps that actually change hair colors. This was considered like breaking, amazing technology in what, early 2018. No, like this is easy enough. So you could try on different hairstyles before you actually get there. We at our company did a web browser where you could try on makeup late at night, or you could just kind of sit there and say like, hey, I want to try this makeup and this makeup. You click different buttons and it would apply it. Our developer who actually did that had all these GIFs with their pull requests. So you get a pull request and Leon's just sending cool stuff. Some of you have it removing background sound or creating background sound because there's AI generating heavy metal 24 hours a day now. Apparently that's a thing. Let me share that with you if you dare listen to it. You've got it playing Pictionary, recoloring old photos, and then even now we've gotten to the point where it's tinkerable, where you can point it out the window and let it tell you when that parking spot is available so that you could run down there and go steal that parking spot. There's just so many fun applications of like what this is doing. And the trick here is that we're seeing it everywhere. So I have a free course for people who want more examples. If you want to see more, what does AI do? What is the terminology? You can see us on academy.infinite.red, and people have really liked the course. It is 100% free. It's a 5-day course, and then you can take this and put it on your CV or your resume for forever. You get a little certificate and everything. Free course, just sort of like AI terminology. It's great for a lot of you who are new to this, and it's a lot of fun. So academy.infinite.red, try the free course. So how do I know people have really enjoyed this? I asked AI. Same way you can sort of identify the expressions of people's faces. You can identify the intent of their messages. You can see if they're very positive. So I loaded up the comments of all these people, and then I ran AI on it, and then got the result of how positive people thought the course was. So people are very, very happy with the course. The comments were over always almost like a full-on 1. And that helped people sort of like identify that they really enjoyed the course. And the ones that are low scores are actually false positive. So I really enjoyed that as well. So free course. People really enjoy it, and I used AI to prove that. But don't worry, I do read these too. I'm not just a robot, so feel free to go ahead and leave comments, and I would definitely read them at some point. So let's talk for a second. Do you all want more examples of what AI can do? Or do you want to sort of like get into the code a little bit or start getting a little bit more technical? Let's see. You know what I'm going to do? I am going to go a little bit more into the technical side of things a bit. Let's get in here. Let's talk about like some of the terminology. So what is going on here? Everybody hears this term called a model. A model's kind of crazy. So you've got this model stuff, and just think of a model as a function. Just think of a model as a function. Just like we saw earlier, data in, like faces, data out, like the sentiment of those people. Now, how does this work under the covers? It's extremely large graph of mathematics. And it kind of looks very intimidating. If you were to do all the calculations this computer was doing, it would take you a long time to even do it on paper, or do it even with a calculator. But that's what computers are great at. And that's what linear algebra is great at, because setting up these nodes and doing the calculations is matrix math. And then we also have some cool computer vision stuff that comes in that helps us identify all kinds of stuff. So where do people get models from as of right now? Number one, there's 3 places. 1, download an existing model because someone already made it. This is like NPM for JavaScript, right? Things already exist. 2, this is the academic way. Write one from scratch and then pass all the data through it. This usually takes a lot of time. And then 3, modify an existing model. This is like going to Stack Overflow, copying and pasting some code and modifying it a little bit. So this is generally called transfer learning. There's 3 different ways you can kind of get some stuff out there. So if you heard earlier, I was saying like some of the models can be reapplied to something else. The problem is that there's a lot of islands in this. Like people are trying to sell their services. It's like, go hit the server and ask the server for stuff. And don't get me wrong, these servers are great, but you can use services like microservices, and then you start to lose aspect of what's going on here. And this is why I love JavaScript, because as you saw earlier, we were running JavaScript directly in the browser, and it was running on your machine, and it didn't cost me any kind of server hosting thing except for to send you the code for you to run on your machine. And it wasn't a toy. You know, for a lot of you, you saw real-time interaction because it has access to your GPU. And if it has access to your GPU, we can get some serious speed out of this. And there's all kinds of cool options. TensorFlow.js is the one I really like, but there's also Brain, and then you can also use things inside of native. So here's an app. There's a free open source repo there for identifying the different images and what they are. Here's a full JavaScript implementation in Brain.js for the open source there as well, for figuring out what number someone has like written inside the box. And these are all running on phones to show an extra point. And then here's a live access to the camera using Food 101, where it's like basically doing hot dog, you know, not hot dog, so we can kind of see these things immediately. So here's a bunch of open source. So I want you to kind of note these. I can give you the slides afterward. You can go dig into these. 3 different methodologies for getting into AI, so you can check into it. But I really like TensorFlow.js. I can do kind of fun stuff. Like I made a website called Nicolas Cage or Not, which is nickornot.com. And that's kind of fun, where it's just a website that's only purpose is to identify photos of Nicolas Cage. So definitely lots of fun things we can kind of do in Chrome plugins and such. Oops, old photo of me. So let's talk for a second about one of the ones that we have here. Not Safe for Work.js is a fantastic library. This one has 4.6 thousand stars. And so we wanted to do something for the community, just real quick, and say, look, big companies have all kinds of people who can watch for indecent content. They violate your privacy and they're inconsistent. So what about letting AI do it for free? And that's why we made Not Safe for Work.js. You can use Not Safe for Work.js if you're like running a conference and you want to make sure that people aren't DMing or uploading like indecent images to a server. It can kind of check those things. And it checks it all on the client and stuff like that. So this is one of our more popular libraries that we created to sort of help people out. We can go into how a model works, but I'm going to kind of skip this part. And it sounds like someone said, I want to look a little bit more at some code. Is that correct? So that's what's great about this presentation. We can kind of jump around a bit. I'm going to go to some more open source demos that use TensorFlow.js, and we can kind of check those things out. So the first thing I could do here, and let me know, I could show, what's the right way to use Nsfw.js for video? That's a fantastic question. I'm going to come back to all that in a second. Let me kind of keep everybody on the same track, and then I will get back to that. I have some with video examples, as well as an example of how to do that in my book. So that's perfect. It's chapter 6. TensorFlow Tic-Tac-Toe.co, which is a fun thing to say. That's why I chose that domain, because it rhymes. I could have had .com, but then it wouldn't have rhymed. So TensorFlow Tic-Tac-Toe.co. If you are enamored by the idea that this website learn from data, then this is a website I created for you. This is sort of like beginner friendly, interesting. The great thing about TensorFlow Tic-Tac-Toe.co is that as you solve it, you can kind of watch it learn and get better at tic-tac-toe by giving it data. So you play games and then you tell it, play a little bit more like this, and then it learns how to play a little bit more like that each time. It's open source. I have a video at the bottom left. So what I'd recommend is, I'm not going to go into this one because people are asking for code, but if you want to understand sort of like watch a computer as it learns, that video at the bottom left is perfect for you. Now this demo is perfect for people who want to see a little bit of code. So let's go into a little bit of code real quick. What I'll do here is load this one up, RPS, TFJS, NetFi app. So I'm bringing this one on over. This one we can interact with in real time together. So if you load this up, you will be training a model directly on your machine as we kind of go through this. So this is a great example for enjoying the idea of like seeing some code and seeing this happen at the same time. So what happens here is Lawrence Moroney made a rock, paper, scissors data set. Does everybody know the game rock, paper, scissors? I believe sometimes it's called Rochambeau or a couple of other things where rock beats scissors, scissors beats paper, and paper beats rock. So it's got this sort of like game. And what happens is as you kind of load this up, I actually can show the code that it's using right here in JavaScript. So the first thing that we're doing is we're going to load this data here. So I'm going to click load and show examples, and that loads about 10 megabytes worth of data for you right here. And so we're kind of checking that out, and this is grabbing the information from the rock, paper, scissors. Yes, rock, paper, scissors, lizard, Spock. Appreciate that. Didn't add lizard Spock because they didn't have the images. And then you see this little panel over here on the right. This beautiful panel is called the Viz Panel. And I love this because this is a little JavaScript friend of mine. And you can see that I can tell it to load all kinds of cool stuff on this panel, and it doesn't actually like have to interface with the page. This comes with TensorFlow.js, and this is a thing that you can actually access and add stuff. So now the data set is loaded. I've had it give me a random set of some of the data sets. So here's some of the hands and some of the things it can do. So I'm going to hide it off for a second here. I'm going to say create a very simple model. Now, what does it look like to create a simple model? The code for creating a simple model as this is called a layers model. A layers model, we just tell it we want a sequential model where we're going to fit a layer at a time. And I say, I want to add this layer. And don't worry if you don't understand this. Just look at how simple it is. Because you can learn what this is if you don't understand it. But the thing is, like, what's the amount of work are you looking at here? Very, very little. Very simple, right? And then I say I want to add another layer, add, and then add this final one, and then compile the model. So I'm going to click create a simple model. And then what I see here, these are those layers I just, you see that? These different layers that I'm looking at here correspond to the parameters that I told it here inside of JavaScript. If you're doing this in Python and things like that, this is very much the same. So one of the great things that you do here is if you learn TensorFlow.js, you kind of learn TensorFlow. It's kind of a combo. It's just that you would be writing Python instead of JavaScript. So the syntax would move ever so slightly. So now I've created this model. Now, what I want to say about it is that it's very simple, and we could go over this, but it's a 45-minute presentation, so I am going to leave this to some Q&A rather than go over it. I'm going to ask the model to figure some stuff out. Now, here's a question. Did I show it any data? No. I have data, and I have a model, but I haven't taught it anything. It hasn't seen anything. So I'm going to say, all right, check the untrained model results. So when I click this, some subset of data is going to go through this, which we call the testing set. And the testing set, which is just a little shaved off portion that will never actually be used for training, is over here. And we can see, look at this. It just thinks everything is paper. This little diagram here is called a confusion matrix, but basically it's saying like, this is what it was, and this is what it thought it was. Currently, our model just thinks everything is paper. You go rock, and it's like paper. You say scissors, it's paper. You show lizard, it's like that's definitely paper. So you can see here, here's the accuracy score that's printed out, and then here it is. So it's not very good. Why? It hasn't seen any data. It hasn't trained. It hasn't learned from data. So now I'm going to say train the simple model. As I click this, it's going to show my model. I want to say it like it's showing it flashcards, right? You go through the flashcards and you say, here, what is this? And then you tell it the right answer afterward. And it goes, okay, that's what that is. And you show it again, flashcards. So what does it look like when you go through an entire set of flashcards? Well, that's what we call epochs. An epoch is one entire time through the flashcards. It's one entire time through the chapter. It's one entire time learning what the training information is. And you can see, if you watch here, it gets better each time it looks at that information. It gets a little bit better. It's like, oh, I didn't catch this. I didn't catch that. And look at this graph as it's going up here. Higher and higher and higher in accuracy. This shows us that it's learning. We can see its score going up. It's getting smarter and smarter and smarter. Now, why do I have two graphs here? I have two graphs here because I have an orange and a blue. The blue one is how it's doing on flashcards where I tell it the answer afterward. And the orange one is how it's doing on flashcards where I don't tell it whether it was right or wrong. So it can't learn that flashcard. It can't just memorize the answers. If you just tell it the same things over again, it's memorizing. But it's not supposed to memorize. It's supposed to generalize. That's what the intelligence aspect of this is. So every time I show it one of these on the orange bar, if it got it right or wrong, I don't let it know. But I do continue to train it with this. And so that's called the validation set. The validation set is a group of information that I don't actually help it learn from. I just make sure that it's able to identify brand new things that are kind of coming out here. So now look at this, it's done really well. Let's take this big failure we saw earlier. So we have this failure where I gave it, was this like, 400 different images or something like that. And I asked it, hey, what's going on here? Now I'm going to give it that data again. Now it has only seen this one time when it failed it. This is the test again, and it honestly, it doesn't remember any of this. So I'm going to check it after training. And we get a second score here. This is getting correct, right? So the amount of code I wrote, let's scroll up for a second here. Create the simple model, get the data, create the simple model, and then this is the code to run the data through the model so it can learn. And then this is what happens. We ask it again, how are you doing? When it was rock, it got rock right 140 times. When it was paper, it got paper right 145 times, and scissors, it got scissors right 115 times. So what's the biggest problem with our model now? Well, we can see that when we give it scissors, it seems to still lean towards paper a little bit much. So you can see it still needs some training. It still needs some work, but this is way better than this, right? We can see that now we have a rock, paper, scissors AI. So if you want to make a game for playing rock, paper, and scissors, you could. And someone had asked a little bit earlier about webcams. I'm currently using my webcam, so I can't double up on webcams right now. I don't have that setting. But take a look at these photos, by the way, just to be fair. Let's go back here for a second. The input data has all white backgrounds, and these are 3D generated hands. So it's not perfect, but I did take a photo of like creating one, and then here you go. I pointed it at the ceiling, and I used my hands, and you can see it was rock 100%, paper 100%, and scissors 100%, so it's good. Now, if you want to test it with the model you just trained on your computer, you can launch the webcam. It might have some trouble with lighting and a bunch of other stuff, because look at these examples. These are so clean, it doesn't really have a lot of trouble there. But I suggest feel free to load up this advanced demo. When you click this advanced demo, give it access to your webcam, and it will do object detection. It'll find your hand and then try to identify whether rock, paper, scissors. This one's way more interesting and advanced and a little bit more fun. So feel free to click on that and check all that out. This entire page is open source. If you come on down here, you can go down to GitHub, and you can not only look at the code directly in the page and see how simple it all is, but you can also actually go to the website that's doing all this code and then load that up as well. So that's everything that you can kind of like get into with this while watching it. Now, very little code, because the code itself, as we saw, doesn't really teach, right? The code didn't do the teaching. Well, there was one spot where we ran the data through, and that code taught and did this. And this is why computers sit there and they train, or people load like cloud computers, and they like load 50 computers up and they train on all those different computers, because they want to get this as close to 100% as possible. And that's the cool thing about JavaScript and TensorFlow.js. You could do this on servers in Node.js, or you could do it right there in the browser and train it on something directly for a client right there. Or you could train it in a server and then use it in the browser. Wow. That's not enough potential, then I don't know what is. There's so many amazing things that you can kind of do with all this. I have another cool example with drawing things and getting sorted into your own Hogwarts house. So try aisortinghat.com. This one shows you how to use a model for something it wasn't originally intended for. Cool stuff. But we jumped into some code there, and just kind of paying attention to time, I want to make sure everything's kind of set. So I want to kind of close up with some resources and give you some time for Q&A. So the first thing I'll say here is that we've taught machines to do things that a human could normally do when trained with a lot of examples. So now in the world of data is everywhere, if I said, hey, I want a picture of a kangaroo, I don't have to go to Australia. I just have to Google search pictures of kangaroos. Or I can pull up the kangaroo subreddit and get a ton of pictures. There's so much data. It's so easy to get a handle on labeled and informative data that I can create things now that were never imaginable before. And that's why I want you to start thinking in machine learning and start thinking in data. Because the trick is, if you think now and you're collecting the right information, you can build all these cool things and a bunch of other fun stuff. So that's why there's a call to action specifically for you. I think that the cool ideas that I've shown you here are just a few interesting ideas. You probably can come up with something way better. And so the important part that I have to do here, this entire presentation's purpose, is to inspire you to think of what AI could do, and then learning the code, as you saw, was not hard. You just need to learn some new stuff, and if you've got something cool to make, you will. Because reimagining everything inspires science. This quote was created by a bot. Yes, that's right. That is not a famous quote. That was by inspirabot.me. So you have inspiring quotes on hand at any given moment. So like I said, I actually have an entire course on TensorFlow.js. I will be giving this course away for free to one of you who are following me on Twitter after this event. Remember, it's at Gant Laborde. You could definitely follow me on there, and then we'll sync up, and I will pick one person and say, congratulations, you got a free $300 course. I hope you enjoy it, or sell it, or give it away, or give it to someone who really cares, and be awesome. If you don't win that free course, I do have a free coupon code, but it's only for people who sat there and listened to me talk, so don't share this, please. It's Gant Talk. So if you use that, you are fine. Academy.infinitered has the free course. Don't forget, if you win or you don't win, you still get the free course anytime you want. I have a Twitter account called Fun Machine Learn. On Fun Machine Learn, I get to post some pretty interesting and cool things that AI is doing today. If you really liked the opening part of this presentation where we were showing different amazing things that AI is doing, you can kite that. For some reason, the hashtag's doing extremely well. Who knows? It's crazy. Very nice. Also, as I mentioned earlier, I have a book coming out. So I wrote an entire book with O'Reilly. It's really awesome. I am very proud of this. Writing a book, this is the second book I've ever written. And it's first time working with O'Reilly Publishing. It's really awesome. In this book, like I said, you will understand all these concepts that I've shown you today, for sure. You'll actually have things hooked up to your webcam as of chapter 6, which is a lot of fun. And I promise that I will make it as entertaining as possible because AI can seem like it's boring. So I'm doing my best to make it fun. And lastly here, I will say AIFYI.com, that's my newsletter, where I kind of take all the fun things that I've been posting on Twitter and I group them up into one email and I put that out once a month saying, check out this cool stuff that's happening in the world. Now people can take a photo and make themselves look like zombies, or now people can do this or do that. The stuff that people are coming up with AI is constantly exploding. And I think that we are only seeing the tip of all this. If any of you have an idea, go out there, create it today. It's easy to become the first person to make something absolutely life-alteringly cool, and as product-based and all the other fun stuff today, because we're just getting into what AI can really do with all this data. I do want to say thank you to the wonderful people at Infinite Red who let me go ahead and do conference talks like this and talk to everybody across the world. And do send me to conferences in person, which I really do miss. I miss meeting all of you in person and showing you cool stuff. So yeah, definitely follow me. And that's my information right there. So that's my Twitter, that's my website, and that's Infinite Red. That brings us up to 48 after the hour. I would love to answer some questions for you and kind of help anybody out on that. So if everything's okay, I'd love to move on to doing some Q&A. Does that sound good? Let me know in the chat. Yeah. And then we can kind of reshare a little bit and go back to something if you wanted to see it. This presentation is very dynamic. It works to the audience specifically. All right, so let me stop sharing here. And I am there. So one question I saw is that a person, Greg, you started using Not Safe for Work.js and you want to know how to use it for video. Two things. One, I've already mentioned that you can do it if you do the book, but the other thing is that example that we had with accessing the webcam inside of the paper, rock, scissors, that will help you out as well if you want to use the website, the open source for that. And the third thing I'll say is this. I would love to maybe make Not Safe for Work.js have like some automated code for working with video. So maybe you could just say like, give it the video element and say start, and then have it and say stop. If we can kind of come up with that API together, maybe we can come up with something that's very useful for people who want to actually use it on video, and we can code that directly into the library. So there wouldn't be this moment of go look it up, Maybe there could be this way where we figure out how it should be used, what the API is, and then we can kind of set that up and either code that together or get some people to code. And I'm constantly working on Nsfw.js, so yeah, that'd be really cool. Definitely let me know if that's something you'd be interested in contributing back to. But if not, you have the open source that you can use to kind of look that up. Hopefully that explains that.
Yeah, hello. Can you hear me well?
Hey, yes.
Yeah, thank you for great demo and great presentation. That was really interesting. I have a couple of questions. First of all, directly related to the TensorFlow.js. So I'm
Yes.
wondering, how do you mark the data as correct or not correct? So, for example, within images, how do you mark that this is the paper,
Yeah.
this is the scissors? What kind of a data structure do you use? And this is my first question.
Perfect. So
I will ask the next one later.
perfect. There is a specific data structure that has created here that is sort of like a fast multi-dimensional array. So you have your normal array, you have 2-dimension, 3-dimension, 4-dimension, whatever. You can keep adding stuff to array. Now, Google wraps that array inside of this thing that can have all kinds of accelerated functions. And they call that a tensor. Technically, a tensor comes from math, where it is an n-dimensional array is a tensor. So that's why they named the entire framework TensorFlow. So when you put data, any kind of data, images, labels, like you were saying, like for images, let's say it was paper, rock, scissors. Let's say paper is 0, rock is 1, scissors is 2. If you put that data into an array and you put it into a tensor, well, now it gets all these accelerated and super fast mathematical calculations that can go access your GPU and be super performant. It is their super performant data structure that allows these things to happen extremely quickly. So you can have your data inside of a CSV and an image. So let's say I had all those images in a folder, and I had all the whether or not image 1 was a paper or rock or scissors, I had this in a CSV or something like that. What happens is before I can put it into TensorFlow, I convert these into tensors. And so loading a CSV into a tensor is easy. Loading images into a tensor is easy. And then I just make sure that they line up. Here's the input, these pixels. Here's what the output should be, the number 1. Here's the input, these pixels. Here's what the output should be, the number 0 inside of tensor form. And then that's what I'm basically training it. This tensor goes in, I want to see this tensor come out. This tensor goes in, I want to see this tensor comes out. So any data, music, audio, visual, maybe even like I can make up something where I want to like look at the top left of an image and then the top right. I could just make that up. Then those become tensors that I put into this thing and kind of like put that in there. So the trick is everything must turn into tensors. And then when it's done, you can turn it back into whatever you want.
Okay, got you. Thank you. And the second part of the first question is, okay, so I assume you will have some tool to transform the like data and labels into the tensors, yeah?
Yes. Yeah. TensorFlow is that. So here's what TensorFlow does for you, and TensorFlow.js as well. They hide the math of like these kinds of things. They hide the GPU acceleration so that you can deal with those things, and they hide the conversion algorithms of those things into their structures for you. If you were a real, like absolute, like I want to do it myself person, you could say, I don't want a framework like TensorFlow. I will write my own machine learning stuff from the math up. And you could do that, but you have an entire team at Google who's optimized and set these things there. So when I want an image to turn into a tensor, I say tf.browser. From pixels. And so then I give it a PNG, I give it a JPG, I can give it a video element. It'll take a snapshot of that video element on the page. I could give it a canvas. I can give it anything. I don't even have to think about what I'm giving it, and it will smartly turn that into a tensor for me.
Okay.
And that's the benefit of a framework.
Yeah, that's cool. And the third part of a question, I've had a talk recently last week, so about the Core ML, which is Apple technology, and in theory you can input some trained model there. So the question is whether you can like obtain the trained model from TensorFlow in some form to import it into the something like Core ML.
Yes, converting models is, so here's one thing I want you all to know. Things that you want to have exist kind of are starting to exist. And they somewhat are good in some spots and bad in others. And, just the other day I saw something, I was like, how does this not exist yet? Like, why did nobody solve this? So here's where we are at with converting models. Let's say you open up Xcode and then you train a model inside of Core ML. You can convert that over to TensorFlow, and then from there you can convert that over to TensorFlow.js. Microsoft is trying to make a model framework that all things can convert to, and then it can convert to all things. They chose to do this. It's called Onyx, ONNX. I'll type it in the chat just to make sure everybody's got that. And their idea is when you convert this over to Onyx, we will be able to bring it, you could either just use Onyx or you could convert it out. And they're putting themselves at the center by creating this. Some people are playing ball. Some people are not. Some people are saying, I don't want Microsoft to have that. I want this other open source thing to have that, or things like that. So what I will say is, yes, Core ML to TensorFlow.js is possible. But if you had said, PyTorch to TensorFlow.js, the truth is, I know a way to do that through going through 5 different intermediate models. And you say, why do you have to do all that? Why would I have to do all that? The answer is because everybody's still kind of figuring these things out, fighting for power. I'll happily show you how to do it. However, until that settles down and there is a winner, or there is a system, or Onyx works for everything, it's not an easy answer right now.
Okay, I got you. Thank you. And the second question is more about your presentation. It seems like really dynamic. Do you have several flows in your presentation, or
I do?
Yeah, that's
I do.
cool.
I'll show you that
real quick. What do you use for this as a tool to prepare several flows?
So this is called Reveal.js. I'll share my screen for a second here, and hopefully this will help. This is called Reveal.js, and the way it works, I'll show you this. If you take a look here, it has a grid style. So I can show you here. So if we wanted to see more about Not Safe for Work.js, I would have gone down further into talking about the training, the code, and the different information it has. If you said, hey, I want to know about how do you make a model, I could have pressed down. But when I press to the right, you don't see it. So the way it looks like to you, and this is a fun little thing, that's down, and this is to the right. And so because I know the presentation, or I could always pop back out and kind of check things, we can actually dig as far into something depending on what the interest of the group is. And that way, hopefully, you all got the best version of the presentation for you, and you all enjoyed every piece of it, and you get to see it. So someone said, hey, I want to see code. That's also why, I guess I could have broken this out so that you wouldn't have seen it. But here's 3 examples of different levels. 1, how does the machine learn? 2, show me some code. And 3, hey, how powerful can we use this stuff inside the browser? Like, what if I have something I want to convert it over and do something that it wasn't originally intended to do? We could train directly in the browser to make one AI do something new. And that's what this example can do. So yeah, it's a very fun thing. Reveal.js if you want to do it by code, or slides.com if you want to use an interface that's very WYSIWYG.
Okay. Thank you very much. That was
Very
really
welcome.
impressive. I will not hold you more, so I will give room for everybody to ask
Feel
their
free.
questions.
Yeah, you got it. All right. Any other questions? Greg.
Hello.
Hello, Greg.
I just wondering, first of all, I'm new on machine learning. Yes, I just started to interest in it. Thank you for your presentation. And
Got it.
I just wondering, do you train your model via JavaScript? I mean, all this stuff, pre-processing, and this is all. I know, for example, this model
Nsfw.js.
Yes, Nsfw.js, train it in Python, but using in JavaScript by TensorFlow. There are ways to train in JavaScript using libraries like NumPy to pre-process data to put it in.
In JavaScript, you won't use NumPy. You will use, so if we use TensorFlow, we have TensorFlow Node. And TensorFlow Node can read an image off of a folder. So you could just say like, here, I want this image and things like that. But you bring up a good point here that there's lots of different ways to train a model, and then you can convert it over to put it somewhere else. Not Safe for Work.js was made in 2017 and 2018, I think. And the amount of work in TensorFlow.js for training was extremely limited. There wasn't good GPU support. There wasn't good node support. There wasn't a lot of things yet. So for that one, it really did make a lot of sense to train it in Python and then convert it over. That's always an option forever, and I love that. However, some of the other examples that we're showing. So for instance, I showed you the tic-tac-toe one. That one is trained in browser. There's the hand gesture recognition for the paper, rock, scissors, trained in browser, as we saw. And then there's another one where you just load a model, but that one was trained with JavaScript as well, which was the AIsortinghat.com, if you want that fun little model. And that explains a little bit. That one was trained in browser. Then in my book, except for chapter 7, where I explain how to convert models, everything is trained in JavaScript in either Node or browser. Every single thing in the book is trained like in JavaScript. I wanted to be as very honest as I could about teaching people and making sure that they only had to worry about JavaScript. However, if you're familiar with Python and you're familiar with TensorFlow and Python, maybe you're more comfortable learning something, or maybe you found a tutorial that's in Python. Do the entire model training in Python, get the model, and then come implement it in JavaScript. Totally okay. So I would say that it's equal right now, where you can choose whichever one you really want. It just depends on how you feel most comfortable, and then it's very rewarding to have it work no matter what.
Actually, I am comfortable with JavaScript, but I started using Python when I started interested in machine learning. And I'm asking, and second, if you can answer, is that can I make transfer learning with Nsws?
Yes. Yeah. If you want to do transfer learning with it, absolutely. Yeah. So let's talk for a second. I just want to explain to everybody what transfer learning is. Transfer learning is that option where you can take a model that does one thing and then make it do something a little bit different. Yeah, just a little bit different from that. And that benefit that you get there is that you can have a lot less examples. You spend a lot less time. You just kind of, you take something and move it over to look at something else. And Nsfw.js, absolutely, you could do transfer learning with it. The way I would recommend to do transfer learning is I could actually, so please don't think I'm pushing the book too hard, but chapter 11 is how I would recommend to do that. You would use it to create a set of features and then train your new neural network on those features. And then I would connect the two together and do what's called fine-tune training to put them together again. And then you have it learn whatever you need to learn that's next. So if you have something that's, if you can improve not safe for work JS, or if you have some feature that it was missing and you want to just add that, yes, transfer learning with Nsfw.js is completely possible. It is a layers model, so it actually lends itself completely to doing that.
Well, thank you.
You got it. Yeah, and if you have any questions in doing that, let me know. And like I said, I do need to, I have all kinds of really great ideas for improving not safe for work JS. Just not all the time I need.
Okay, but let me explain. I've worked in some commercial project with video interview, and I have to distinguish some violence, yes, in video.
Yes. Oh, violence. Okay, gotcha.
If it present, yes, and
yeah, okay.
I'm just using it like Spike, yes, just investigating different ways, and one of that is mentioned library, and most videos is like I see you now. It's recording from cameras by laptops, and nothing strange. But in my tests, when beautiful girl with good I don't know, décolleté, if you understand me, shows me some strange results in some points. Like this is excuse me, porno, but this is not porno. This is natural, because in a picture a lot of skin. Yes, not not clothes, but skin. And I thinking to transfer learning to improve in my cases. Yes.
And here's an interesting thing that's very important here. In this might be blowing some people's minds, is that you don't get a perfect accuracy. Like if I'm asking a computer what's 2 + 2, in AI it's almost a little bit set to opinion. And then you get to like set the opinion of what it is that you want. And that's called type 1 and type 2 errors. So let me give you an example. In detection of pornography, it is important that in some cases it has a lot of false positives, because you don't want anything to get through in a particular case, or you want to flag all the things. And so it's aggressively pessimistic, and it's giving you a lot of false positives. Well, you might want that, because you might be like, I can't let one thing through because this goes to a Twitter board or something like that. So give me all the false positives and set, and I want to manually check these, and those are great. And so because technically a human is like 99% accurate, whereas the model Nsfw.js is between 90 to 93% accurate. So the truth is, you want it to like do most of the work, and then probably you want maybe a human to interact at some point. But there's a cost here. It's extremely pessimistic in that particular structure. Now, let's say that you were using it to stop people from uploading something like Facebook does. Well, in that case, you don't want it to be as pessimistic. You want it to sort of share type 1 and type 2 errors a little bit more, because you're stopping a user experience completely, and you're not flagging it for review. You're like I'm not even letting them upload this. Well, now it's more important to be careful rather than it is to be pessimistic. So the truth is, your models can be trained where you have acceptable amounts of how it errors. And the truth is, for things like pornography, people are usually expecting very aggressive and very protective errors because the chance of letting something through is more dangerous. You might get that same kind of thing perhaps in like cancer research, where it's better to get, maybe it's better to get more false positives than it is to let one person with cancer through. But then maybe you have the situation where this is talking to the person directly and you don't want to make them alarmed. So maybe, that's not as true. It's up to you as the scientist to assess the situation and then set what your acceptance levels for certain amounts of type 1 and type 2 errors are.
Yes, thank you.
You got it. I believe there was another person who had their hand up.
Yeah, that was, but this person lowered his hand, and I have a question if this person still wants to ask a question. I'm not sure.
All good. I know that it's easy to get all this terminology.
It is still,
there you go.
Okay, great.
Hello.
Hello.
Hi.
I have a question. For example, if I have incredible ideas, how can I check, can I implement it by machine learning or not in general?
Yeah, I would say that's a great thing. First thing I'd say is think about the data. So let's say I had somebody come to me and they had a really, really, really good idea. And they said, oh, this is my idea. So I say, that's fantastic. Do you have data so that we could train the model as you saw us like put information through the model? I think their thing was like, hey, I want to check sales leads, or they want to do sales forecasting. And the trick is they wanted to know with the certain indicators, how well are sales going to happen for the rest of the year? How many sales do they think they should have next month? And this would affect their ability to hire. The problem was they weren't tracking any of the metrics or any of the information to create an option for sales forecasting. And so then it kind of instantly stopped because, as you see here, data is the driver for that. Now, what I'll say is if you have the data and you think that if you could, go off for a year and train yourself on that data to be able to do something with it, like let's say, how some people can do handwriting recognition. They could say, oh, I know Gant wrote this because that's his handwriting. You could train yourself for that for years. You could get really good at it. You could identify all the different people's voices or handwriting, things like that, based off of data. Well, that's exactly what you can teach a machine to do. However, if you don't have the data, or if you even having the data could never actually figure out, what's going on, like perhaps the stock market, you're just like, I have all the stock market data, but I don't know what it should be paying attention to. I don't know what's important. Hopefully it'll tell me. It's a lot harder of a problem. So you need two things. Actually, I'll say three. One, a fun idea, a great idea, something that you're going to fight for a little bit. Because in my presentation, I can show you where I failed. I have this one spot where I tried to do something, I failed, and then I had to figure out the next thing, and then finally I got it to work, and it was super fun. But I had to be willing to fail a few times. So one, something you really care about. Two, you need the data. And three, the data actually has to be able to give you a way to predict the results and have features that can actually predict the results. And then with that, yeah, you're just learning TensorFlow away from trying it out and seeing how accurate you can actually get. Maybe it'll be 80%, maybe it'll be 90%, maybe it'll be 100% accurate. You can find out after you do it.
Okay, and if I determine the data, do we have some service when can I find the model and find which the model more fit to my data?
Yeah, there's a lot of services out there that can sort of like judge, different pieces against another, different structures against another. More of the aspect is like you can do that yourself. You train it and you get 93% accuracy. So you change some things and you get 94% accuracy. Once you kind of understand the different things that you have in there, you can do that. But there are services like AutoML, which are meant to say, here's the data, here's what I want. Can you try a bunch of stuff for me? And then sort of give me a result that works out best. So AutoML is sort of this new terminology of things that are out there where you're giving it your metrics and then it tries a bunch of things to figure out how to like train it properly. Do I show it this information or that information? So that way you can get different models and then gives you the best one that fits your parameters. So that's the easiest way, I'll say. The second easiest way is to go with a service like, just telling Amazon, they have things like Recognize and SageMaker and cool things like that. And then the last one is sort of like what we're doing here today, where you could train the model and then you could say, okay, this is cool. Now I want to, this is how I want to tweak. I want to understand what I'm tweaking here and how it actually affects the speed and the progress and all the other fun stuff. So that's the third one. And that's not a service. That's just information. So I say you have to choose what level of dealing with AI you want to do. The easiest is to look for an AutoML or an existing service.
Okay, thanks. That's all I have.
You got it. I see a quick question over on the right side. Have you tried TensorFlow.js with Internet of Things? Yes. I've put it on a Raspberry Pi, and someone is doing this really cool project with lights. There's a hashtag where you can kind of see a lot of really cool things that people are doing. Hashtag made with TFJS. That hashtag there is a fun one to watch, where you can, myself, I've done a little bit, but there are people out there constantly building fun stuff. And if you have an idea for putting TensorFlow.js on a particular device and having it doing something interesting or fun, let me know. I did put it on a Raspberry Pi and then have it say intruder alert whenever it detected a person. So I did that. I don't know what I was good for. I haven't ever made a talk out of it or presented it anywhere. But it's kind of cool. My goal for that one was to point it at my car. And if anybody tried to touch my car after midnight, I was going to have it turn on a light on them or something like that. But yeah, you could definitely put it on. JavaScript goes everywhere, right? So TensorFlow.js goes everywhere with it.
So guys, do you have more questions? I think that we can have like a few minutes.
My camera decided to die. There it is.
Maybe it's a sign that we, oh yeah, we have a question.
One more question. Does TensorFlow require only NVIDIA GPU or other also can use?
That's a great question. So TensorFlow.js, as I was talking about here, so TensorFlow can work on a CPU or a GPU through NVIDIA. But TensorFlow.js has this intelligent backend finder where it can work with, if you only have CPU, it uses CPU. You can also tell it to use WebAssembly, where it'll go to WebAssembly with threads for your browser. You can tell it, it automatically will select GPU through WebGL and try to use WebGL to access and speed itself up, unless you tell it, do not use WebGL, try to only stay on CPU, but it'll try to go ahead and use that. And then the third thing that it can do is there's another version of WebGL where it's accessing the GPU through the browser called GPU.js, I think, or WebGPU. That's what it is. And they're doing setups with that as well. And that seems to be outperforming WebGL, by the way. So by default, it'll try to find the fastest way to do a calculation. If you want to choose to use WebAssembly or all these other things, it can use that through the browser. As long as your browser has access to your GPU and those libraries can access it, it's fine. If you're using TensorFlow directly on your machine and you're doing it in Node, I believe the only thing that if you are accessing the GPU directly through the instruction set locally and not through the browser's cool interface, yeah, you're stuck with NVIDIA and CUDA setup for GPU acceleration. But like I said, going through the browser, it has a different way of like kind of determining and using an interface for optimization. So there's trade-offs either way.
Okay, thanks. Because you know, with the Bitcoin boom,
yes, it's hard to get those GPUs.
Cost of GPU, yeah.
I know. One of the things that you can do, weirdly enough, is like if you've got something that's real GPU intensive and you want to do some serious calculations, consider moving it to the cloud for a little bit. You know, there's scalability with cloud services to share training amongst quite a few different GPUs. And Google, through TensorFlow, has their TPU, which is their tensor processing unit, which is a piece of hardware made specifically for processing tensors. And that is even faster than GPUs. So you have access to that hardware only through, at least that I know of, is going through the cloud service. So if you had like a real monster of data that you need to calculate, it's worth taking a look at cloud stuff. Not safe for work.js, which I did right here on this GPU on this computer right here. I ran it for 1 week on this GPU to get like the maximum results I could get. And so that was really fun, having my GPU just burning for a week. But I probably should have moved that to the cloud. Was that?
Like kind of heating.
Yeah. I should have moved it to the cloud. I really should have. That would have been much faster. I was just being lazy. So.
Okay, thank you.
You got it.
One more question from me.
You got it, Greg.
Can you say something about, if I could remember, distributed learning?
Yeah. Federated Learning?
Learns not on server, on computers distributed, yes? In the browsers, yes, of different people.
Yeah.
And is this related to TensorFlow.js or something?
It will be. There's still a lot of work to be done on federated learning. So just for everybody listening, there's this idea. So earlier we did the example where I was, we all made faces, and then your local computer identified your expression and then sent it off to the server, but it didn't send like a picture of your face. And so this is great for a couple reasons. One, it's great for privacy. And two, it's great for speed. So we can do this with model training as well. Let's say I create a model for, finishing emails, and I send it off, and each of you have your own little model running on your browser. And what happens is, as you update these things, it starts to figure out how you like to finish your sentences in an email. And so it gets customized, it gets identified just like you. Now, here's the problem. It gets smarter, but I don't want to send my emails back to Google, right? And that's the problem. If I send my data back to Google, they're able to read my emails. Now, this is a problem. But if I train my local model, it gets smarter, and it just kind of learns preferences and adjusts its weights, and it doesn't actually have your information inside of it. And then I send that model back to Google. They can make their system smarter based off of training that happened here without them having any of my personal information. So I help train their model by training one for myself and personalize it. This is the basic concept of federated learning, and this is great for what TensorFlow.js could do. However, remember how I told you, you're like, I can't believe people haven't done this yet, and I can't believe this hasn't been created yet, or things like that. What you're talking about, I believe, is a couple of steps away from them doing it, because I think they're doing some security concerns, because they don't want to do it and not have the security in place. So you might have heard of FLOC, F-L-O-C, which is like a federation of learning of cohorts. And what happens is, I think the whole idea of FLOC, as well as encrypting models on a machine, is going to need to be in place before people can say they're okay with this process. There's still some more security in place. Now, it doesn't mean that you and I can't go write this tomorrow. We could, but I think that there's more things kind of coming out there that they say, we need to be careful about X, Y, and Z before this turns into it. But is it going to use TensorFlow.js? Yeah, that's definitely going to be a main part of how this all works.
Thank you.